So, starting off a new week, and I just thought I'd show one of these jobs that I've got in. I've had a customer that's dropped 2 A series cylinder heads off to be lead free converted. So the first one, the seats, I've just put the initial bore onto them, but also I just thought I'd show how bad this workmanship is. It's really been hacked away with a grinder by someone. Also this bung here is sunk, so I'm going to have to reface that, try and correct some of this. I'll put the seats in it first, skim it, and like I say, hopefully some of this will disappear. The second head that he's brought down, another A series head. So I just thought I would show this angle here. I think I'm just trying to get it where I can see. You can see where the valve has been seating right inside the seat. So it's been right down there. Where somebody had a go at porting it, they've taken a load of meat out of a soft seat because it hasn't got lead-free seats in it. And it's actually started to pull the valve through the valve seat. So now it's lost its angle also, which I can show that on the valves. Let me just find a bad one. So instead of it being a 45-degree angle, it's probably ended up pulling through, stretching the thread, and I would say it's more of a 70-degree angle now. I don't know, is that picking that up? If I hold it against there maybe. But basically the angle of the seat and the angle of the valve, where it's pulled it through, it's just destroyed the valves and the seats. So I'm going to have to, you can see it on this inlet as well. So it coming through a lead-free seat anyway, so that's no problem. I'm going to have to try and correct the inlet seat, but there's nothing I can do with the valves. So the customer's valves are now scrap. But if I grab a standard valve, a new standard valve, which I've ordered for him. So it's not really showing the 45 there, but if I hold that angle against that angle, you can see that it's not quite square. I don't think the camera's picking it up, but anyway, it is. It's not brilliant. However, I've just spotted one major problem there. That's a triple groove collet, and that's a single groove collet. So I'm going to have to speak to my friend Simon at Nevlock and just let him know that 4 of these valves are wrong. The valves that I've had sent through a triple groove when I wanted single groove, so I'm going to have to send those back. I'll probably end up keeping them, to be honest. It's more hassle than what it's worth sending it back. So, but anyway, you can see the fault that I've got with the valves and the seats. So I can still correct them because I'm doing 2 cylinder heads for the customer. One set of valves are okay once they've been reconditioned, so I've shot blasted them just there, and I've polished the stems. I've just got to reface them, so that job won't be too bad. I'll use them valves to set the seats up in this cylinder head as well, and then I'll ring up Simon at Nevlock and get the right valves sorted out. So that's the counter bore all done now, ready to take the lead-free seats in the 100E engine. So the next thing I'm going to look for is one of the tools that I use for installing them, which I'll show you those. I'll keep them over here. These are really handy. They're actually listed as a bearing driver set, but they're a great product for putting the seats in. Just get that a bit more settled. So they're all different sizes, so all I do is find the right size for the outside diameter, and what I'm after is it just a little bit smaller, so I know that I'm not going to foul on the cylinder head or the block at all. And then that just goes onto this installer, and then if I've got one, I always like to try and find one for the centre, just so it can locate inside the seat better. So like that there, and then it has a little nut that locks all that on, but I snap that off, so I won't be using that. What I do is use the ceramic glue to lock them in. Make sure that there's no bits of swarf in the counter bore, because you don't want that to get below the seat. Oh. And just make sure the ceramics all the way around the seat like that. Then it's hammer time. So I've got some of these seats that are in the freezer cooling down to shrink them, ready to fit. So I'm going to go and replace them with the ones that I want to fit. Now is trimming the tops off the seats with the seat cutter. While the seat cutter's set for the right outside diameter of the seat, I've just brought the seat out. I've just brought the cutter out a little bit more, and then what I can do is trim the tops of the seats down. This lip that's left on here, and then as soon as it just touches the cast iron of the original cylinder block, I know that I'm level. I find that just a really easy way of getting the top of the seat to the right setting. So that's what this machine is doing now. So it's just self-centering. It's now locked off. I've turned the cutting speed up a little as well, just so I can get through it quite nice. Where the seat is so hard, you can sometimes just see the machine moving a bit. When I'm cutting the seat, it's important that that doesn't happen, but when I'm actually just trimming the seat down, it's not so important, because all I'm trying to do is get it flat. So I'll just show that. So this is turning at 120 revs per minute, and straight away I can just see the machine just starting to move a bit with a heavy cut. And then just bring the cutter back up to the top. Release the clamp on the cutting head. Release the magnet. Get all the swarf off it. I really enjoy machining old engines like this. I just enjoy seeing how things change, and you can see the more modern material being pressed in and fitted, and just giving something really older a new lease of life again. Well, that's the seats in. So now I've got to put the angle on them and get them to the right depth. Open them up a little bit, because the inside diameter of the seat is a little bit smaller than the original one. So I'm going to cut the seat on it first, then open up the inside diameter, then do the inlets, get them all at the same depth, then it's reface time. So another job that's come in this week is this crankshaft assembly. So it's crank, front pulley, flywheel and clutch assembly, and it's off a VW Beetle dragster. So it's coming for a balance, so I thought I'd run through how I go about doing that. Everything is balanced individually, so instead of bolting it all together and balancing it as one big assembly, everything gets balanced separately. So I balance the crank first, then I change the settings on the machine, I balance the flywheel and the front pulley, then change the settings on the machine again, and then balance the clutch assembly. So with this machine, you have to put all the crankshaft or vehicle data into the computer. So the first thing to do is to weigh everything separately. So I just use these scales here, weigh it all separately, make a note of it, and then start to add the details into the computer. So what I'll do now is time lapse that happening. So that's it, that's all the crankshaft details in. This part of the machine picks up the RPM, which uses this reflective sticker there. The machine's set up so it's got the distance between the correction points, the radius out, the weight of the crankshaft, so all the details are in here, and the speed that we're going to turn it at. Then this left hand plane here is the flywheel side of the crank. The right hand plane is the front of the crank. So we'll run this up to 800 RPM, and then it would say here exactly how far out it is in grams and the degrees as well. So I'll just do that bit now. Taking it off time lapse to show you this. This is the crank running. This is it building the speed up. And then once this green bar's gone across, it tells us that it's worked out the calculation of how far out it is. So the crank's quite a lot out at the front, and it's out at the back as well. So we're going to have to correct that a fair bit to get that bang on. Well, there we are. The crankshaft for the Beetle drag car's now balanced. When this lights up green, that means it's in the tolerance, and then you've got the target here to show you exactly how close it is to the tolerance. But as long as it's green, we're all good. Like I said, it spins at 800 RPM. How I've done it by grinding these edges, and then I've polished them back up. So now I need to fit the flywheel and the front pulley, which I've weighed them. So I need to change the setting on the machine. We press the button that says rotor, and at the moment for the Beetle it says that we're on bearing mode 1, which basically means, if I can get this closer, bearing mode 1 is here. So the two triangle parts are the bearings on the balancer, and it's saying that we take weight from R1 and R2 inside the rollers. So what we need to now do is change the machine to bearing mode 2. So the rollers are on the inside, and we're taking weight off R1 and R2 again, which is the flywheel and the front pulley. So now we've got the flywheel, the crank and the front pulley being tested, and I've run it up once, and if I show you on the computer screen of the balancer, it's not very good at all. This is the flywheel here. So I've changed all the settings in the machine so we're balancing in the right on the right planes. But this side, the flywheel side, is so far out. I mean, it's shown as 85.69 grams. It's 24.1, which is the front pulley. But what I'm going to do is I'm going to try and bring this down first to see if it affects this at all. What I don't want to do is try and bring these down together straight away, because once this one comes into balance, it might throw this out the other end. So I'm going to work on the flywheel side first, and come up with an SD card fault, so I'm not sure exactly what it's previously recorded on this on the flywheel and clutch, but basically the flywheel was 88 grams out. So what I've done is I've put plasticine opposite to where it says it needs the drilling, just to try and give me a rough idea of where I've got to take the metal from. And what's really interesting is somebody's had a go at balancing it there, factory balancing, and that's exactly opposite where it needs metal out. But as you can see, they've also had a pop at it there too, which there is opposite. Is just take a bit of meat out of here just to see how it affects the balancer now. So there we are. I mean, I'm quite happy with that. That's the first drilling I've done in the crank, and it's brought these down, so they're pretty. So that's the flywheel and the front pulley now within balance, and I'm pleased the front pulley's come in balance. On it, knocks it out of balance by 43 grams, so I need to adjust that now. You see that? So that's now, the clutch has come into balance, and it's brought the front pulley in now, so that's all ready and good for the customer. And that's 800 revs per minute in a dragster Beetle. That's the dragster all finished now. We've got all his data of good and bad tests there, so I can give all that to him. It's nice that the machine prints that. So I'm shutting the machine down. So another job that I've had turn up today is this exhaust manifold. I'm not sure what it's off. Customer wants it refacing. These are just always a nightmare to try and reface. It's normally trying to jiggle brackets here, there and everywhere to get it level to skim. So I'll get this mounted and then I'll record the end result, but as you can see, it's looking very, very worst for wear. So hopefully if we can do it, or if I can do it, it should look good at the end. So that's the exhaust manifold completely refaced now. That's in a lot better condition. It took a lot to get it flat, so it definitely needed a reface, but that's all good now. So I've been limping around all day with my foot and back from racing at the weekend, so I'm just going to quickly deburr this and then go home, but at least that's that one finished. The next job that I'm doing today is back onto the National hot rod engine, because I've had some of the engine bits turn up for that now. So the other day I bored it, I've skimmed it, I put a nice little chamfer on the top of the board just to help the rings when fitting them. So now I've got to hone it. Now what I always try and do on the race engines, and if any customers ask for it, on the engines that I do a few of, I've got things called torque plates. And what a torque plate does is it simulates the cylinder head being clamped. So what that should do is, once these threads have pulled up with the cylinder head on, sometimes it can distort the bore slightly and it changes the bore size. So when honing with a torque plate, what that's basically doing is trying to twist the block into the shape it would be, or the bore into the shape it would be once the cylinder head and the main caps are done. So I've got a guy that makes these torque plates for me. I've got Crossflow, BMW, Zetec, Pinto, and this is the one for the Vauxhall XE. They're really well made, they're solid steel, so they're heavy, they really do the job. And what's really good about these is he's also machined them so they run on the original dowels. So what I like to do is make sure it is exactly as it would be on the engine, fit the gasket, torque it up, torque the main cups up, and see what that does to the block. So I'll fit that, torque that, and show that being honed. So on the Vauxhall XE National hot rod engine, I've now torqued the torque plate down, I've torqued the main caps up, and I'll show you exactly what it does to distort the bore. So if we just go off, say, cylinder number 3. So when I bored this, I bored it with about 2.5 to 3 thou left to take out. So if I get this close. So at the top of the bore, it's left out exactly what I bored it to leave out. And then as we go down to the bottom of the bore, it's now at 4 thou. So by fitting the main caps and the torque plate, just in that one part, it has pulled the bore 1.5 thou out of shape, where on some of the standard pistons 1.5 thou is the clearance. So exactly 90 degrees opposite, it's still roughly the same. In fact, it's 0.5 thou loose compared to where I bored it, 2 thou loose to around from the other side. And as I move up the bore, it's just completely moved the bore. So, I mean, it's quite important on race engines, well, any engine I suppose. Well, that one, 3 thou. Now there's no way this can be the boring bar, because I bored it with the same cutter on the same day, and I've checked it with without the torque plate on, and whoops, and the bores are perfect all the way down. But that one there's once again 4 thou. So it really is distorting the bore at the bottom. But I can correct that with the honing, that's not really a problem. But I think that's good to show just how much a bore can move from just bolting the cylinder head down. So that's the block all to size. So the last thing I'm going to do is take the torque plate off, replace the stone for some cork, and then just give it a really fine finish just to improve the surface finish of the bore. And then that's all ready to be cleaned. So I just want to end vlog 25 by saying thank you to everyone that has subscribed and enjoyed the videos so far, liked and left comments. If you've enjoyed this video, then in the comments section below, just leave the word valve, please. Yeah, I just wanted to say a really big thank you to everyone. If you can, keep sharing it. I'm desperate to get the subscribers up even more. So awesome. Thanks, guys and girls, and thanks to my wife too for spending all the time editing. I know it's a pain in the arse, but we're all worth it.